So now we will test our decision tree. Think a few things I might have changed. So I just tried to do this and the file wasn't on the desktop, so I had to restart the video, so I just decided to redo this few minutes that I've already recorded. So let's just try to fix the error that I found. Where was the error? Okay, it was here. So the evaluate method, that might have had a spelling mistake, so if you already caught that, that's good. I was probably looking at the exact method header. I was looking at my notes. I don't really look at the screen or the keyboard when I'm typing. I'm looking at another screen usually. So I think that's it. And then also comment this stuff out, these methods, because we don't use them. I think I just did those for extra. Not sure why. And then take the generic type T out as well in our decision tree. Before there was a type T here like this. Take that out. And I think that's all I did. So after that, we'll go back into our main method and we will, I've already done this, but you can import java.io, .file not found exception, or the whole package, whatever. Throw file not found exception, you can call it main or driver, whatever. Expert, doesn't really matter what you call it. Print out that string, so you're having backplane. Create an object without a generic type. Put the path, I put the file on my desktop. That's a Windows path. I'm not sure how Mac is. And if you're using Linux, it should be something similar. So we'll just put the file on. I'll try to upload that file to GitHub. So by the time you watch it, it should be there. I'm not sure if I'll put the code up there. I'm not sure if I'll have time to do that, but I will put the file there so you can follow along. And then so you can write these lines, and I'll just take a second here while you copy that out. Just watching a little bit of 4X, actually getting back into it. I used to kind of work on algorithms for 4X back in the day, and I kind of took a break from it. Trying to code a trading bot. Well, I kind of started it. It's just for fun. I'm trying to use TradingView syntax, but they use like PineScript. And there's not really too much docs on it, so it's kind of complicated. Like I coded an indicator in PineScript, that was easy. It's kind of just like Python, but it's a little different. But to backtest it, there's like special ways to do it, and I'm not sure how, because you can do it in PineScript, and like the user interface where you can just click and do it is doesn't really work as good. So I'm like trying to figure out how to do it. Is it really worth it? Should I just test it on live data, whatever? But usually backtesting, like if you use MT4, it's a little tricky, but there's like some special ways to do it. But it all depends. There's some experts out there, but you can do it yourself. You just kind of have to look around. So anyways, I hope you've copied that out by now. And we will start. We'll just save and run just to test it. So it's okay, so did that already start? So we'll click play. So did the pain occur after a blow or jolt? If you're not sure, maybe just put Y or N. So we can just click, you can just type here Y or N. I think it's ignore case, so it doesn't matter if it's capital or lowercase. I should say, if we're not sure, where it came from. Whatever, we'll just do Y. Do you have difficulty controlling your arms or legs? Let's just say yes. And it says emergency, you may have damage to your spinal cord. That's great. So we'll click it again. Let's just say no. Do you have a fever? No. System warning signals. So let's just say after I work out, I get stiff. My body gets stiff. So then we have inflammation of the joint. So it just has it's like a doctor, like a kind of like a hospital doctor or something, or like a family doctor, whatever, walk-in clinic doctor. So let's actually jump into this and see what's happening here. So let's put a breakpoint here, and we'll debug it. Okay, where'd that go? It's down here. We'll crypto's dumping right now, by the way. It's pretty interesting. I think ETH fell by like 500 points. Bitcoin fell by like 8,000. I think it retraced a little bit. So anyways, we'll just continue here. So we have decision tree expert points to new decision tree. We have a path here. So the path is your path where you put the file. Excuse me. So we'll step in. We're gonna go into that constructor. The file's right here. No, it's not showing us the file. Okay, so object is being instantiated. It should show us the file here, or at least the line. So we'll step in. File input file points to new file. File name. There's our file, or well, there's my file, and your file should be there too. If you're using IntelliJ, it shows you nicely the path and all that stuff. Not sure if VS Code does the same. I don't think Eclipse has a debugger as good as this. So we have our file, so we're using the file class. That's a built-in class. We're calling it input file. We're setting it to new file and file name. So we're just creating a file, right? Then we're going to create a scanner to scan the contents of the file. So we'll step in. It's not going to give us any internal code there. Here it's just going to, I don't think it's going to give us any internal, oh it might. Nope. So we'll say, okay, we'll scan our file. Scanner scan points to new scanner. We'll scan that input file. It's not showing us anything about the file. The scanner has its own class with lots of stuff. Stuff you'll probably never really look into. Radix. Well, we did do a radix sort, I think. Well, I recorded that video. It's not really that fun. It's just like a bunch of cues, I think, stored in a list. I'm trying to look if it's getting us the file. Doesn't really look like. Maybe he'll hit view here. Nope, nothing in there. So that's fine. We'll just leave it like that. So we'll say int number of nodes points to scan.nextInt. No, so number of nodes is 13. And you can do this too. You can pull up the file. I don't know if I'll be able to pull it up. You won't be able to see it, so I'll pull it up on my other screen here. So you can do that too. So just pull the file up. Where do I have that file now? Okay, I'll open that up. Okay, so it has 13, then it has a string, a bunch of strings, and then 3-digit numbers with spaces. So we'll say, okay, we got 13, and 13 is the number of nodes. Then we'll say, okay, scan.nextLine. It's showing us what it has. Nope. Number of nodes, points of scan.next in. Nothing in particular. Whoa, someone just lit a firework or a firecracker. I think it was a firecracker. Outside my house somewhere on the street. Like it's Remembrance Day, you're really gonna light firecrackers, or it's almost Remembrance Day. Not sure if they have that in your country, but here in Canada they do have Remembrance Day. Okay, so we have scan.next line. So we're gonna step in. It's not really showing us what it has. I think it just goes to the next. No, maybe not. Okay, so we did go through that. That line we just executed that line. Showing us what happened there. So it has the buff, or the BUF, I don't know what that is, but it has all the strings on there, including the numbers, so it has all the data there. Right there we can see our data from our file. So it's kind of cool that IntelliJ does that, but not sure why they call it buff. Stored in a heap apparently, or a heap char buffer. Some kind of heap of characters, alright. So they're using a data structure to hold the data. Not telling us, it's not telling us exactly where the scanner is, but we're gonna see. Scan.next line may just go to the next line, it may not actually so that's what I thought. Maybe it just goes in front of that D. So did the pain occur after a blow or joint? I think maybe it just goes in front of that D. Did it really collect the whole string? Did the pain occur after a blow or jolt? I don't think it did. It might have. It's not really showing. I thought it did show it here last time, but I'm not getting anything here. Nothing in scan. Fortunately not seeing anything at this time, so we'll just not worry about it. So we'll set we'll hit the next line. Int root points is 0 left and right. Root points to 0 left and right are null, so it's not going to show that. Then here we'll instantiate a list, and that list is going to store be of type linked binary tree object, so it's going to be of linked binary trees, and those linked binary trees are going to hold strings. We're going to call it nodes, and we're going to instantiate it to a new array list. So this is using polymorphism. So can we get anything in that? Nope, nothing at all. Wonderful. But we have our nodes, which is an array list, which is a list. Is there anything in there? Nothing right now. It's instantiated, has a memory location at 1170, but I guess there's nothing in there at the current time. Size is 0. So we'll say, okay, we'll go to this for loop for int I equals to 0. I is less than 13, I plus plus. So index 0 to 12. That should be how many strings there are. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so 12 strings. So, no, I thought there's, no, sorry, 13 strings, index 0 to 12, I think. So now we'll say, for int I is equal to 0, I is less than 13, I plus plus. So on this iteration, I is equal to 0, right there. In the debugger you can see under variables, if you can see the highlighted blue, it's I equals to 0. Then we'll say, okay, we'll add to the nodes array list add at index 0 a new linked binary tree of type string object, and and the element is going to be scanned on next line. So what do we say up here? Scanned on next line, so perhaps it went to in front of the D, as we said. And if we step in, will we get anything? Well, nothing happened there. Will we step in again? Array list. Step over. Someone Java developer wrote all this stuff. It looks familiar now, doesn't it? So we're done. Didn't do anything. So it's not showing us, unfortunately. Actually, you know what? It will show in our nodes. Did the pain occur after a blow or jolt? So now, you can see that it took that whole string. So it did go in front of the D. Then it did. Then we said scanned on next line again. It did take. Did we say scanned on next line? Yeah, we did. We did say that here and here. So here it took the. We said this one scanned on next line 13. Maybe that just number of nodes points to scanned on next int. And then maybe when you transfer from an int to a string, it goes to the front of it. And then, so we'll see how it works here. So for int I is equal to 0. So now I is actually 1. So I is equal to 1, I is less than 13, I plus plus. So we should have I increment to 1 there. There you can see we have our string there in nodes of index 0. We'll say nodes.add to index 1, a new binary tree, and then scanned on next line, so it's going to scan the do you have a fever. So for any confusion, it's not really showing it. Sorry, I had to move the mic. I don't have the foam on because I dropped it in water earlier. When it was at that 13, I think when it went to scanned on next line, since it was at int, it was originally a scanned on next int, it actually just went to the front of the next line. That's what I think. I remember seeing that laid out somewhere, but right now I can't find it. But anyways, we'll just add to index 0, do you have a fever? So you can see here, do you have a fever? And it's just going to keep doing that, so we'll just go through all those. Add them all now. Where are we at? 6, 7, 8, 9. We at 10, 11, 12, done. Okay, so now we have all our nodes that we're going to create our decision tree with. So now it might get a little bit more tricky. So we'll say, okay, while scan dot has next. So it's saying, okay, well, while scan, where is scan? So what did we say, right? We said scanner. At the end, we said scanner. We said scanned on next line. So at the end of that, we should have our scanner pointing to, you may have a muscle or nerve injury, I think. It's not really showing us where the scanner is. at this current time. Has next pattern closed. Mod count 30. So that's okay. We do have something because it was holding something. We know that. We just said scanned on next line. Oh, sorry, where were we? We said while scan dot has next. So we have the scanner which had scanned something, so now it's holding something. So we'll step in. It says position 515. Does it tell us that anything? Position 515. Position. Tell us where that current position is. Don't see that, so that's okay. So we'll just say, okay, we'll root. So after all those strings, right, we have those numbers now. 3, 7, 8, 4, 9, 10, 5, 11, 12, those ones. So now we're after that string. Then below that we have a 3, 7, 8 number. And we'll say, okay, we'll root points to scanned on next int. I think I may just take the 3. So there we go. Root points to 3. Then we'll say, okay, well, left points to the next int, so that's going to take the next int on the same line, not the next line. So if that makes sense, I think. So then we'll say left equals to scanned on next int. That should point to 7. There we go, and right points to 8. Next int. Scanned on next line, so it's going to go to the next line. So yeah, so I think that's what happens after an int. It goes, so it can be to the middle of the page, right? Then when it says scanned on next line, it goes to the next line. And when it's on that line, then it retrieves the string on that line. So hopefully that makes sense, and we've figured that out. So now we will go to the next line. So now the scanner would be on, it's going to be set in front of 4, 9, 10. It's going to be in front of that 4 to the left of it. Then it's going to say, okay, well, nodes dot set index 3 0, 1, 2, 3 to a new linked binary tree of type string. So where's our constructor here? So the constructor, overloaded constructor with 3 parameters. The one that's that's going to take a T element linked binary tree left and a linked binary tree right is going to be this one. It's going to take 3 parameters. It's the only one that takes 3 parameters. So we'll say, okay, we'll set index 3 to a new, so put a tree in index 3. That's what it's saying. So we're gonna get for the first parameter, which is the element, we're gonna say nodes dot get. Well, what's nodes? That's our array list. Well, root. What's root? Do we have this? Nope. Root is 3. So nodes dot set index 3 to a new tree, and nodes dot get root, which is 3. So 3 will be the root. So sorry, do you have persistent morning stiffness will be the root. So this is where you kind of need to write it out. So maybe I should write it out somewhere. Yeah, I remember how I did this now, so I actually wrote this out. So how am I going to do this? let's see. We'll have our array list dot set. Can I write it down here? Yeah, maybe I could just put them here. So we'll say nodes, which is our array list. We'll say, okay, that's index 0, index 1, so index 2, index 3, which is we're at 3. Or we'll just put here, index 3. We just put like a semicolon. And we'll say, we'll set nodes.set root, which is index 3. We're going to place a new linked binary tree there of holding string objects. And in that linked binary tree, we're going to go to the linked binary tree constructor, which takes 3 parameters. Then the element is going to be our array list nodes.get index 3. So that's the root. Technically, that's going to be the root. So we'll say, do you have persistent? This is going to get long. Persistent morning stiffness. This may take itself an hour. Hopefully not. Do you have persistent morning stiffness? As a question, whatever. Or we can just leave it like that. Do you have persistent morning stiffness? As a string, of course. So that's going to be here. Root's going to get set to a new binary tree node. So our binary tree node root. Then so yeah, so that'll be the root, the first one. Okay. We're in internal code right now. Is it not really showing us that constructor? Nope, it's not. Where's our index 3? So there's our index 3 now. Do you have persistent morning stiffness? I wonder why it actually put it like that. Or with that string in the middle. So we'll say, okay, nodes.get root. Do you have persistent morning stiffness? So nodes, so get the array list, right? Dot get. So before we change that, it was just, do you have persistent morning stiffness? Dot get root element. So that was the dot get root element. I go here. Nodes.get root dot get root element. So pretty much that root is 3, and we're just going to get the element. Get root element, is that in binary tree node? Sorry, let me just have a look at that. Get element, set element, no. Might just be in our linked binary tree. So here, get root element, return root.get element. New linked binary tree, nodes.get root. So it's just going to return us that string. That might be unnecessary here, but that's fine. Then, so for the next part of that constructor, it takes a left. So the left, it takes a left in parameters. So the left is nodes.get left. So what was left? We might have to restart that. If you already clicked step in, I apologize. Because we skipped so now it changed what left is, or it doesn't show it anymore. So we'll just try to get right back there. Step in, skip. All that. Step in. Okay, here we go. Left is 7. So we'll say, okay, well the left child is nodes.get left, which is 7. See the doctor if pain persists. So we'll just say that's the root. We'll say here, see doctor if pain persists. That is left. And the right is 8, I think. Was it 8? Yeah, 8. So 8 will go here. You may have inflammation of the joints. So we'll say right. Or we can swap these here. We can put that here. So index 3, root. Do you have persistent morning stiffness? Left. Whoops, what's happening there? So left is see doctor if pain persists. Right we'll say here. Which is 8. You may have inflammation of the joints. Whoops, sorry to hit the mic by accident. There's no mic home at the moment, so you might feel those. Apologize for that. So you may have inflammation of the joints. And that is our right child. So we have root, left child, and a right child. And that should be it. The next one will be 4. So we'll set that. Great, it brought us here. So we'll skip up and then we'll see our left. So it says see doctor if pain persists. That's our left child. Excuse me, so it shows the left child first. Then the root in the middle. Do you have persistent morning stiffness? And then on the right child it has you may have inflammation of the joints. So I don't know how many we have of those, maybe like 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 4 or 5 of those to do before we connect them. So while scan is still holding something, oh right, no, not holding something, because remember, if you can remember, we were at 3, 7, 8, we passed those and I said the scanner is sitting on 4. Hopefully, if you can pause the video and go back if you forgot. Hopefully you still remember, because I can't even remember where that is from. We'll say, okay, we'll say while scan dot has next. So we'll step in. So root points to scan dot next in. I think it is 4, so we'll say 4. Hopefully. So there's 4. Then left points to scan dot next int, that's 9. Right points to scan dot next int, that's 10. So 4, 9, and 10. Then it's gonna leave those in. It's gonna leave the it's gonna leave that 4, 9, 10 is going to go to the next line in front of 5. So we'll execute that line. Then we'll say nodes.set. We'll set our root, which is index 4. We'll instantiate that index 4. Maybe I should just put these on different lines, which would make sense. So we'll say, okay, index 3 is that. And below that will be index 4. Here's index 4, our pretend index 4. What's happening there? Hopefully you can see that, by the way. I'm just trying to keep all that data on the same line. Excuse me. So we'll say nodes.set root, which is index 4, so we're going to set index 4 of the array list. 2, we're going to instantiate a new linked binary tree object, storing string objects. Then we're going to go to that constructor in linked binary tree. It's going to take 3 parameters again. We'll say, okay, well that's going to get nodes dot get root, which is 4. So it's going to say, okay, go to our array list and get that built-in method. If you want to find that method, go to the Java Oracle docs, search array list, you should find that. Then we'll say nodes.get index 4, which is, do you have a sore throat or runny nose? Dot so in index 4 it has an element, so it's going to retrieve that element, which is a string. Do you have a sore throat or runny nose? So that's going to be our root here. Root, do you have a sore throat or a runny nose? Hopefully not. Then the root is done. Then in the constructor we have, so our t is element, the root points to that element, so that's going to be the root. So root takes the element. We could have called it root and just pass in root as well. We could have named this element, we could have named it root, and maybe it would have made more sense if you're a little confused, because at this point I'm like, well, maybe root would have been a better name to put there. We could have said root points to new binary tree node, or we could have said this dot root points to new binary tree node of type t root. That would have worked. Maybe that's more confusing. Whatever you think's better. So we get that the binary tree node root is going to point there. And of course that root has its own left child and right child, which are going to be null. Because look, when we instantiate a binary tree node, with an element, that's going to be the root, right? The root element's going to get passed there, and the left and right are going to be null. So we're going to be like, okay, this root string, which is holding the element, which is a string. For example, do you have persistent morning stiffness? Its left and right child, which it has one, it's just there, or it has them. They're just pointing to null at this current time. And when we connect the tree, we're going to point each of these lines to another line. So we're going to pretend there's a line going from this line to the line above, like that. And we're going to make the edges, or the branches. That's when we're going to use that null place that's currently null. So for now, we're back at that constructor. So we have our root set, which I just explained. The root is set to that element, and its left and right child are null. Then that part's done. Then we'll say, okay, here, the left child is nodes dot get left. So left is 9. So go to 9. So 9 is so the array list at index 9, right? Nodes is our array list. Dot get index 9, which is left. Left is set to 9. So when we put left here, we're just referencing 9. Then we'll say, we'll go to our nodes array list, index 9. We'll get the string, see doctor to address symptoms. That'll be our left child. Because linked binary tree, the constructor that takes 3 parameters, right here, 3 parameters in order. The next one is the left child. So then we'll say root set the left to left.root. So before I said that these nodes are going to point here, for just kind of point them, say this is the root here, and point the left child, this root's left child is here. And so what I really meant by that is that this left child is null. A few minutes ago when I said that, so I apologize if I confused anybody. This left child here, its nodes are null. So it's this left child, this is the root here, its left child is here. Now this left child of this left child, the subroot, is set to null, or points to null, and this left child's right child points to null. So that hopefully that resolves any confusion. So we're back at this constructor. Root.set left. So take the root. What's the root? It's right here. Do you have a sore throat or a runny nose? That's the root. So its left child is going to be where are we? Decision tree nodes.set. Okay, right here. So nodes.get 9, right? Nodes.get left, which is set to 9. So we'll go to our nodes array list, go to index 9, and get see doctor to address symptoms. So here we'll put the string, see doctor to address symptoms. Now, we'll go back to our constructor, and we'll say, okay, this root, which is, do you have a sore throat or runny nose? Its left child, so we'll say, okay, that root, set its left child to left, right here, this tree, dot root. So it's a little confusing because it's creating them as trees. So it's like, okay, well here's a linked binary tree, and guess what? It's going to take a linked binary tree and a tree. So hopefully don't get confused. It's just saying, okay, well we're going to set it to this tree left's root, which is really just the elements. So it's just a different way to do it. We could have done it with nodes, of course. So it's just a different way to do it. Don't worry about it. It doesn't even go here, right? The compiler doesn't even actually go. It should. It's glitching out. It should go through this constructor and show us how they're getting set, but it doesn't, so that makes it difficult for us. So we're going to have to kind of just like actually do it ourselves. So that can happen sometimes. IntelliJ does have its fallbacks, like that's one of them. Doesn't happen too often, but it happens when there's too many. It can happen when there's too many method chains and parameters and stuff like that. It can get confused. So we have our left set. Then we'll get our right. So we'll say, okay, well what's our right child? So okay, we'll say our right child is, we'll go to nodes.get right. What's right? Right is 10. So we'll say our array list nodes, which is right here. Go to index 10 and get right, which is 10, index 10. you may have a respiratory infection. So here we'll put right, then we'll put the string. You may have a respiratory infection. I don't know if I spelled that wrong. It's getting late here. Infection, respiratory. I can't even spell anymore, so. Puratory. You may have a respiratory infection. Right there, done. We have that node complete. Root, left child, and right child set. Done. So you see, it's not jumping into the code. It's just kind of skipping it over, which isn't helpful at all. So okay. So we'll say okay. We'll index 4. Do you have a sore throat or runny nose? That's the root. It's left child. See doctor to address symptoms. It's right child. You may have a respiratory infection. So we can continue. How many do we have left? We knocked out 6 of them. 1, 2, 3, 4, 5, 6. So we have about half left. 1, 2, 3, 5, 6. 1, 2, 3, 4, 5, 6, 7. So another half to go. Just gonna take a sip here. Sip of water. You guys can maybe continue to do it yourself, but I do want to show you, because there's a part where it connects all the nodes. It ends up being like just a few of them. It just points them, maybe like 4 of them or 5 of them. It just kind of quickly sets them at the end. So I wanted to kind of show you that. Because we just did 4, 9, and 10, I think. So now we'll do 5, 11, and 12. So let's just continue with it. So we'll say, well, scan.has has next. So we'll say, okay, well, while scan has a line to process, we're at 5, 11, 12. It's in front of the 5. So we'll step in. Root points to scan.next line. Next int. That should be 5. Then scan the next int. That should be 11. Left points to scan.next int. That's 11. Right points to scan.next int. That should be 12. Excuse me. So we have 5 as a root, 11 and 12. Scan.next line. So go to the next line and go to the left side of the 1. That's what it's going to do. Then we'll say, okay, nodes.set root, which is 5. So we'll say, okay, go to our array list. Go to index 5. And I'll just create another index here at the bottom. 5. We'll say root. So we'll say, okay, we'll set the index root, which is 5. Instantiate a new link binary tree there. Hold strings in it. And the parameters it's going to take is nodes dot get root. So get, do you have pain or numbness in one arm or leg? And so it's going to say okay. I'm not going to go through those constructors because we've done it a bunch of times, so hopefully you understand. But we'll say here, where am I? Nodes.get left. So we'll say, okay, well, the left child is nodes. Go to our nodes array list. Dot get left. What's left? Left is 11. We'll go to index 11. You may have a sprain or a strain. So we'll say, okay, our left child here is, you may have a sprain or a strain, comma. Then we'll say, okay, well the right is nodes.get, right, which is 12. You may have a muscle or nerve injury. So we'll say right. You may have a muscle or nerve injury. Done. Done. So now we'll go to 5. Actually, no, it's not even set yet. So we'll step over. Now we'll go to index 5. So we'll see. Do you have pain or numbness in... The root is, do you have pain or numbness in one arm or leg? The left child is, you may have a strain or a strain. The right child is, you may have a muscle or nerve injury. So that's our subtree. It's sitting right there. We have 3 subtrees. Index 3, index 4, index 5. Each has a subtree on it. With a root, a left child, and a right, they all have those 3 roots, 3 left children, and 3 right children. So we should have 9 nodes there now. So let's say while scan dot has next. So while scan has I don't know if I might have explained this differently earlier, but right now I think what it says is while scan has data in the file. I might have kind of said something around that, maybe not exactly, but I think now I'm remembering that's exactly what it is. So while scan has something in that file, or a line to process, something like that, has something to process, then we'll say, we'll step in. So I think after 5, 11, 12, we're on the left side, we're on the next line on the left side of the 1 in that text file. Then we'll say root points to scan.next int. So root points to 1. Then left points to 3, scan.next int. Then right points to 4, scan.next int. So 1, 3, and 4. Then we'll say scan.next line, so it's going to go to the next line, to the left side of that 2. So it's going to be waiting in front of the 2 for next time when we access our scanner. So then we'll say, okay, nodes.set root, which is 1, index 1, back here. We'll say, okay, nodes.set index 1 to root, which is 1. Do you have a fever? So hopefully you don't have a fever. We'll put here index, actually we'll go here then. We're going to go up here since it's going back. We'll put index 1 here. We'll put root here if you're following along. Then we'll say, so again it's just going to, it's saying nodes.set index root, which is 1. Instantiate a new linked binary tree there to hold string objects. And the parameters it's going to get, so the element is going to be, which is going to get set to the root. Right here. Root is going to get set to a new binary tree node and pass the element into the root. So we'll say nodes, we'll access our nodes array list dot get root, which is index 0, 1, right there, index 1. Get the root element, do you have a fever? So I'll put the string here, do you have a fever? Then for the next element here, the left, sorry, just move the mic for a sec. We'll say nodes.get left. So we'll say we'll access our nodes array. We'll get index left. What's left? Left is 3. So 0, 1, 2, 3. So this is, okay, this is going to get great. We're going to put that whole thing here. So we could just copy it. These are going to get really long, the lines. So we're going to say, okay, well, do you have a fever? Is there a better way to do this? Probably not, unless we were using a paint or something. So we have our root, which is do you have a fever? Then its left child is going to be nodes.get index 3, which has 3 other nodes in it. So we're going to say, okay, its left child. What we could do is just put the index here. So we could say the root is do you have a fever? And its left child, so we'll put its left child here. Its left child is index. Its left child is nodes.get left, which is 3. So that's its left child, so its left child is going to be the root. Do you have persistent morning stiffness? So let's just put the index here. Left, maybe a shift semicolon. I don't want to make it too confusing, but we'll just say, okay, well, we're going to place the whole root there. We're going to place a subtree under that child, so we're just going to leave it like that. Then we're going to say, okay, well, its right child is nodes.get right. So if you can see what happened there is that whole line is its left child. So really it's going to point to that root. So do you have a fever? And then its left child is going to point to do you have persistent morning stiffness? So it's going to be a subtree with it. So a branch, then like a subtree, and then a subtree. So it's like branching out, right? Our tree is branching out into tree nodes. So we'll get our right child. So it's nodes.get right, which is 4, index 4. So we'll say, okay, well, its left child is that root with that subtree, and then its right child is index nodes.get right, which is 4, index 4, which is do you have a sore throat or runny nose? That's the root. With it has a left child. See doctor to address symptoms, and a right child. You may have a respiratory infection. So hopefully you don't have any of those things. We'll just put that there. And then 3 was done. Maybe we can just put like used 3. I just heard another firecracker outside my window. Noise cancelling mic, so I don't think you heard it. Actually, I don't have the mic foam on though, not sure if that helps. So we'll say we did use 3. We did use index 3 and we did use index 4. So we'll just put another used here. Just so we know that these are our main branches and we use those ones. So we'll say, okay, index 1. So we have index 3, still have those nodes. But index 1, we have like a super node. It's going to show us. There we go. So it's not going to tell us exactly where they are. We have to know that ourselves. It doesn't even show a root, unfortunately, in this tree. Like it doesn't like show the normal root and stuff. Root node, because it's kind of setting up the tree in the list rather than the actual tree itself, because again the linked binary tree it isn't a tree, it's just a general tree to create nodes. It doesn't like have its own like linked binary search tree structure or like a heap structure or anything like that. So basically it needs something to store these nodes, so we have to use a list. So right, we like think about it, this is just a general tree, and what it does is just create tree nodes. There's no actual stuff that we can access. Except actually we do have something we can access here. So we have our root. So it's like a tree within a tree is being stored in an index. So you have a root, do you have a fever? So each every time we instantiate a node, it instantiates a new linked binary tree, so each one is a tree basically, and we're connecting the trees. It's not like we have one tree and we're setting each branch into one specific thing. So you can see like here, index 1, it has a root, you have a fever. Its left child is, do you have persistent morning stiffness? That's the next root of 3, right? Do you have, so we have its left child is 3. Do you have persistent morning stiffness as a root? So I guess we do have some tree nodes inside the indexes. But I'll show you how it's different in a sec. So do you have sorry if I confuse anyone, by the way. So do you have persistent morning stiffness? So we do have the left child here. Do you have a fever? That's in the root. Then its left child is in array index 3 of nodes, and that has a root. Do you have persistent morning stiffness? Right there. It has a memory location at 1397. Then it says, do you have persistent morning stiffness? Its left child is, see doctor if pain persists, and its right child is, you may have inflammation of the joints. Those left children should be null. Those left children should be null. To root, do you have a fever? You may have persistent morning stiffness. Did we set the right? I can't remember now. Did we set the right? Yeah, we did set the right one. So we have root. Its left child is array index 3, which is what we just said. So root, its left child is array index 3, which array index 3's root is, do you have persistent morning stiffness? Then we'll go back to root. Do you have a fever? That's the root of index 1 at least. Not the main root. We're gonna fix those later. That's what I mean. Like each one is a tree. That's what I was trying to say. Each one has its own root. So each one is a tree, and we're going to connect the trees. It's not like it's one data structure where it's just one tree and it has one root. This is like it has an array list. Like we have an array list, and each index is storing a tree, and we're going to connect those trees together. It doesn't really have a structure. This tree doesn't have like an actual structure, like it's a binary search tree. You can only have two nodes. Like this one, we can probably create more nodes if we want to. But so we're at root. Do you have a fever? Then we did what its left child is. Then its right child is index 4, which its root is, do you have a sore throat or runny nose? Its left child is, you may have a sprain or a strain. Do you have a sore throat or runny nose? Sorry, I meant index 4. So root, which is index 1. Do you have a fever? Then its right, we know what its left child is, and its right child is here, I think. Do you have a sore throat or runny nose? Right, it's index 4. and its left child is see doctor to address symptoms. That's correct. And its right child is the right child is you may have a respiratory infection. That's correct. So it's do you have a sore throat or runny nose? Left child, see doctor to address symptoms. So these ones should be null, which is true. So everything's working there. It's different though because each array index has its own root. So there's not one general root, so it's not really a structured tree. That's what I was trying to basically say. We just have like a bunch of trees here. So hopefully you understand. So we are at, where are we now? Do we do 1, 3, and 4? It's not going to show us. Oh, yeah, actually, yeah, we have root is equal to 1. We must have done 3. And we must have done 4. So I think we're at the left side of 2 now. So while scan.has has next, root points to scan.next int. That should be 2. Left points to scan.next int. That should be 5. And right points to scan.next int. That should be 4. Oh, sorry, that should be 6. So 2, 5, and 6. Then it's going to go to the next line. It should go to the, after 6, it should go to the next line, which has 0, 1, and 2. It should go to the left side of the 0. Then nodes.set. Root, which is array index 2. Where's our nodes? Right here. 0, 1, 2. So we'll put an index here. Whoops. To 2 here. Array index 2. Then we'll say the root is, so nodes.set. Array index. Root. So nodes.set. Root, which is 2. So set index 2. We're going to instantiate a new linked binary tree there, storing string objects. And in the linked binary tree, we're going to take 3 parameters again. It's going to take a root, a left, and a right tree. So our root will be nodes.get root, which is, do you have difficulty controlling your arms or legs? Done. Then we'll say its left child is 2, 5, and 6. 2, 5. Okay, so its left child is, so the next one we're going to do is nodes.get left, so the left child is going to be nodes.get left, which is 5. So right here we're going to input the whole thing for 5. Whoops, sorry, I just touched the mic by accident. So here we'll say a left I will say a left here. We'll put shift semicolon and we'll put 5 here. Index 5 is our left child. Index 5 is our left child. And we'll say that should be good. So we're going to put that whole line here. I think we're just kind of briefly just skip over it, because we kind of know what's going on. So here we'll just put used / /use / just to show that our branches have been used. We don't really need them anymore. They're stored here. And then we'll say, okay, well, our right child is 6, index 6. So nodes.get, right is 6. So it's emergency, you have damaged your spinal cord. So we'll put here the string. We actually will need a right here, and then a string to emergency. You may have damaged your spinal cord. That should be done. So we have a root, you have difficulty controlling your arms or legs. The left child will be all that on index 5, or in index 5. Then we'll say you may have damaged your spinal cord for its right child. That will be done. That was index 2. Everything should be in there. Do you have difficulty controlling your arms or legs? And there you go. Then we'll say, or we'll go to the next one. The last one, is it? This is the last one. So we'll say while scan.has has next. So while scan has a 0, 1, or a 2, which it does, has a next line. We're at the left of that 0, I think. So we'll say root points to scan.next line. That's 0. Left points to scan. Sorry, not next line. Next int. Left point to 1. And right points to scan.next in, which is 2. So 0, 1, and 2. Scan the next line, which should just be empty. So therefore, I don't think we have, when it hits the loop, it'll just say, it'll exit out of the loop because we won't have any more data, I believe. So here we're at our nodes array. It says nodes.set root, which is index 0. So we'll say, okay, we'll just go to the top of this one here. And we'll put a index 0 here. Shift semicolon, we'll put a root. And we'll say, okay, well, nodes.set root, which is index 0. So we'll say, set our nodes array list of index 0 to a new linked binary tree object holding string objects. Then we'll say the root will be nodes.get root, which is, did the pain occur after a blow or jolt? Then we'll say here, the left child will be nodes.get left, which is 1. Is that 1, I believe? Yeah, so it's nodes.get 1. So nodes.get left, which is 1, will be its left child. So we're going to put that whole thing here. And put the whole thing there. Whoops, we should write left here. So that whole subtree within a subtree within a subtree or something is going to go in the left child here. Then we'll put then we'll say the right child is nodes.get right, which is 2. So nodes.get right. So the right child is going to be nodes array list dot get right, which is 2, array index 2, right here. This whole thing here with the nodes inside of it as well. And we'll say the right child is array index 2. That should be it. So now if we have array index 0, did the pain occur after a blow or jolt? There we go, that should be it. It's not showing it like how we should if we click this. Did the pain occur after a blow or jolt? That's our root. Our left child will be, do you have a fever? Should be. Do you have a fever? There you go. And its right child is, do you have difficulty controlling your arms or legs? That's the root. There you go. So you can find the rest of the nodes in there. I think I've explained it to the best of my ability. I hope you can understand. That should be it. So it's at that while loop. So this condition should be false because we're below that 2 now. There's nothing left. So that's correct. And then our tree object reference variable that we never used until this exact moment, we're going to set that to nodes.get root, which is 0. So tree points to array index 0. That's going to be our tree, our final tree. And it's done. Then we can evaluate it. It's really just going to say, what happened? Where are we? Why are we in this thing? I didn't want to go through this method because it's a long method. It's like what we just did times like 10. See how many passes that is? Oh my god. I'm not sure what happened there. Why did it do that? I'm not sure. Why did it get there? Because we went expert.evaluate. Expert.evaluate. So let's just stop that for a sec. Go to main method. Move the breakpoint there to the next line. Step in. It might have glitched out. I think it did glitch out. So while current.size, maybe that's where it might. I thought we were up there when it did. Okay, so we'll just stop there. Re-debug it. Step in. So it's saying, okay, current points to the tree, scanner scan, points to new scanner, system.in, input. Skip that. Print out current.get root element, so I should print the root. Where can I print that here? Console, right? Did the pain occur after a blow or jolt? Then you can choose N or Y here. It's going to go through the decisions. So that is everything. Yeah. So if this video helped you, you can subscribe if you want to see more free coding videos, and also more videos on investing and trading, free stuff, free educational videos. So I'll see you guys in the next video. Thanks for watching and take care.